These are the 7.1 notes, and today's objective, we're going to be factoring the greatest common factor from polynomials, and GCF is what we indicate as the greatest common factor. Now, if you remember from your lower level math classes, greatest common factor is the largest factor that two or more numbers can be divided by without a remainder. So just as a review, like here on number 1, if we're trying to find the greatest common factor of 32, we'll first want to list all the factors of 32 and 44, and then find the greatest number that they both share. Now remember, a factor is the numbers that multiply together to be 32. So I'll list the factors out of both of these. So the factors of 32 are 1 and 32, 2 times 16, and 4 times 8. The factors of 44 are 1 times 44, 2 times 22, and 4 times 11. So the greatest number that they can be divided by without a remainder is 4. So the greatest common factor of 32 and 44 is 4. Now let's move on to finding the greatest common factor of just variables. So I want to find here on number 4 the greatest common factor of y to the 4th, y to the 9th, and y to the 6th power. Now this is actually probably a little bit easier than finding the greatest common factor of numbers. Now remember that y to the 4th is the same thing as y times y times y times y. Y to the 9th would be 9 of those y's. And y to the 6th would be 6 y's multiplied together. So what these three have in common are 4 y's, which we'll write as y to the 4th. So that's the largest number of y's that will go into all three of them. So the greatest common factor is y to the 4th. Now you don't really have to write these out. You always pick the one with your smallest exponent. You know each one of these variables has at least 4 y's in them. Now on number 6, I've got both numbers and variables. So the first thing we want to do is find the greatest common factor between our numbers. And we know the greatest common factor between these variables, again, is this one that has the smallest exponent, so they all have at least 4 x's in them. So I know right now that the greatest common factor for sure is something times x to the 4th. Now I'll just find the greatest common factor of 18, negative 6, and 9 by listing the factors out of each. The factors of 18 are 1 times 18, 2 times 9, and 3 times 6. The factors of 6 are 1 times 6 and 2 times 3. And notice I didn't pay attention to the negative here, because if all three of them had a negative, then they would also have a negative in common. But since 2 of these numbers are positive and 1's negative, then they don't share a negative. So we're just going to be concerned about the positive numbers that they share. Then the factors of 9 are 1 times 9 and 3 times 3. And I only listed that 3 once. So the biggest number that all three of these have in common is 3. So the greatest common factor of 18x to the 7th and negative 6x to the 6th and 9x to the 4th is 3x to the 4th. They all share a 3, and they all share at least 4 x's. Okay, so we found the greatest common factor so that we can continue on here by factoring, which is really our main objective for today. We want to factor the greatest common factor from these polynomials. Now remember, a polynomial just means more than one term. And so these terms are not alike, and so there's more than one term here. I've got the term 32x and the term 2. So I want to find the greatest common factor of 32x and 2. And what this is going to look like is we're going to have a greatest common factor and then a parentheses with everything that's left over here and here. So the greatest common factor always goes on the outside of the parentheses. So the greatest common factor between 32 and 2 is just 2. That's the biggest number that's going to go into 32 and 2. And since the 32 is the only one that has an x, they don't share an x. So now I've just got to figure out what goes inside the parentheses. Now remember, I'm going to be distributing here. And when I distribute, I want it to equal this original problem. So 2 times 16x is going to give me the 32x. And then 2 times 1 is going to give me 2. So if I distribute, I do get what I ended up with. So when I factor out the greatest common factor from the polynomial, I get 2 times 16x plus 1. Now let's factor the greatest common factor from the polynomial 4x to the third plus 10x squared minus 6x. So the greatest common factor between 4, 10, and negative 6, first of all, they aren't all negative, so they don't share a negative. So the greatest common factor between 4, 10, and 6 is 2. Now remember, that's going to go outside of parentheses. So I'm going to have a 2 out here. And then I've got to take care of the greatest common factor between my variables, x to the third, x squared, and x. Now remember that we want to choose the one with the smallest exponent. So the smallest exponent is this one. It just is x to the first power. So they all share an x. Now I need to figure out what goes inside my parentheses. And this time there will be 3 things inside my parentheses, because remember, I'm going to distribute here with all 3 of these so that I can end up with what I started with. So first of all, 2x times 2x squared would give me 4x to the third. Then 2x times 5x would give me 10x squared. And then finally, 2x times negative 3 would give me negative 6x. So when I factor this polynomial, I end up with 2x times 2x squared plus 5x minus 3. That's the polynomial with the greatest common factor factored out. Okay, the last example is number 10, and this time I've got r times z to the 5th minus 3, and then minus z to the 5th minus 3. Now this minus sign right here between these is what separates our 2 terms of our polynomial. So what do these 2 terms have in common? Well, they both have a z to the 5th minus 3 in common. So we're going to factor that out. And what's left in this first term is r. Then I'm going to put my minus sign. And what's left in this term is, you would think it's nothing, but it's really a 1. And here's the reason, because remember, I want to distribute here, and I'm going to be distributing z to the 5th minus 3 times r, and then z to the 5th minus 3 times 1. If I multiplied it by 0, the answer would be 0, and I don't want it to be. I want it to be z to the 5th minus 3. So I have to put a 1 here. Remember, there's really a 1 in front of that parentheses. So this one factored out is z to the 5th minus 3 times r minus 1.